Oops, I need to learn more how to do this kind of thing. Hello, everybody. I'm glad to be here. Good morning, good evening, good night, whatever you are. So today we have one more episode to talk about Java technology and yes, a little bit more about Spring at XG channel. So if you are new here, please subscribe and get more information about us. Also, we have an amazing blog and also our website. If you want to know more about XGeek, so go in your favorite browser, check out xgeek.io, where you can see about us, some news about technology, what you're doing, and yes, more job opportunities. So if you are a Java developer, if you're a Python developer, if you are uh, DevOps developer, please join us, check it out to get more information. Today, let's talk a little bit more today, right? So today we're gonna talk more about Spring, especially the news, the features, and what's going on. And we have an amazing speaker. She is Microsoft's MVP, community co-organizer at several conference in Brazilian. So with you, put your hand together with to Camila. Hello, Camila.
Hello, Otávio. How are you?
I'm fine. Oh, hello, Lucas. Lucas
Hello,
Lopez.
Lucas.
Hello, Rita. So that's your show, Camila. So I'll give you a spot. So break your leg.
Okay, let me share my screen. Okay. Hi, everyone, and thank you very much for the invitation to present here at XGeeks channel. And thank everyone who is watching this live now or watching the recording later. It's awesome to be here with you today. Today I'm going to talk about the main Spring projects and what each one can be used for, what problems they can solve. We will not see examples of code, but a summary of each functionality of some Spring projects. Let me pass. So who I am? I am Kamila Santos. Actually, I work as a backend developer at Digital, that is a fintech Brazilian. I am community organizer of some communities in Brazil and also book co-author, and I am Microsoft MVP in developer technologies. First of all, what is Spring Framework? Spring Framework provides a comprehensive model of configurations for Java-based applications. It allows us to focus on developing the application, already leaving most of the configurations ready or extremely simplified for us developers. Spring has features for dependency injection, data validation, tests, access to database, development of web apps, integrations, and can also be used with languages such as Kotlin and Groovy. And I think it's all. First, we speak about Spring projects. Let's talk about Spring architecture. Spring architecture has some models. The first is core container, container. And in the core container, we have some models. We have the bean model that provides bean factor, which is an implementation of factory pattern in Spring. We also have the core model in core container that provides the fundamental parts of the Spring, including IOC, inversion of control, and dependency injection features. Sorry. We also have the context model that has a medium to access any objects defined and configured. I run this. And the application context interface is the focal point of this model. And we also have the spell model in core container that provides a very powerful expression language used for manipulating and querying an object graph at runtime execution. In the data access container, we have some modules about access database and an access data in general. We have the JDBC model that provides a JDBC abstraction layer that removes the needs for some JDBC configuration and code. We also have the ORM provides integration layers for popular object relational APIs, some like JPA, Hibernate, and others. We also have the OXM that provides an abstraction layer for supports objects, XML, and mapping implementations, for example, Xstream, JXB, Castor, and others. We also have JMS, Java Messaging Services, that contains features for producing and consuming messages. And for last, we have the transaction model in data access container that supports transaction management for classes that implement special features, special interfaces, and for all plain old Java objects. In the web container, we have some features. We have WebSocket that provides support for WebSocket-based applications and communication between client-server apps. We also have Web Container, that is Spring MVC. That's a servlet container that contains Spring MVC for web apps. We also have the web model that provides web-oriented features such as initialization of the IOC container using servlet listeners and a web-oriented application context. And we have the portlet model in web container that provides the MVC implementation to be used in a portlet environment. And we have some models that is not part from containers, but is part from Spring architecture. The AOP is the expected-oriented programming that allows us to define method interceptors and point codes to cleanly decouple code. Aspects provide integration with Aspect-J. Instrumentation provides class instrumentation supports and class loader implementations to be used in servers. And Message provides support for STONP, Simple Text-Oriented Message Protocol, as the WebSocket subprotocol to usage in applications. And finally, we have the test model that supports the test of Spring components with JUnit or TestNG frameworks. And what is Spring Boot? Spring Boot allows the creation of an application quickly, having an embedded server, the Tomcat, a starter, the Spring Initializer, where we can choose the initial dependencies of the application, health check of the application without the need to configure several dependencies using XML. This is the Spring Initializer interface. We have some features in Spring to solve some problems. The first is for web apps. Spring abstracts most of the settings and already provides a basis for your application to run. Through Spring Security, we can easily add authentication to your web application and connect and query the database with Spring Data, for example. We have some features for microservices using Spring Cloud. And here is an example for some projects for Spring Cloud. We have API Gateway, config server, service registry, circuit breakers, Leaf, and others. Spring Cloud provides several tools that assist in the development of microservices, such as config server, load balancer, circuit breakers, gateway, and others. Service discovery enables microservices to easily discover the route of other services that need to access. And the most projects used for service discovery is Spring Cloud Eureka, that is part of Netflix open source, and Spring Cloud Console. For Gateway, Gateway has the role of being intermediaries in our requests. And in Spring, we have Spring Cloud Gateway and Zoo. Config server allow us to store configuration set centrally and generally in a repository in GitHub, GitLab, and others. Load balancer, we have the Ribbon and the Spring Cloud Load Balancer because Ribbon is deprecated. Fang is other project for Spring Cloud. Pang facilitates the use of clients in a declarative and simplified way. For serverless applications, we don't need to worry so much about allocation resource of other features related to application server. We work as function as a service with Spring Cloud Function. And for event-driven and for event-oriented applications, we have the Spring Cloud Stream that has integration with Kafka and others serves for streams. For batch, for processing larger routines and jobs in general, we have a Spring Batch project. Spring Data is responsible for abstracting a large part of our work with database, such as writing simple queries, source save, search by ID, and update, and others. Spring Security supports authentication using JWT or all services, develop all of server obeying the client and connection to authentication using social network, for example, GitHub and Google authentication. And it also allows us to work with scopes. Spring webflux is one of the newest Spring projects. Spring webflux has 3 years. Spring webflux can be defined as a parallel version to the already known and widely used in Spring MVC, the servlet version. Spring webflux having as main difference the support for reactive NIO, non-blocking, and input and output strings for supporting the concept of backpressor with the net server, coming by default embedded in the architecture. From version 5 of Spring Framework, we have a reactive part in addition to the servlet structure that already exists. Each module of this is optional. You can use servlet part and the reactive part using webflux. And for example, using webflux, then use Tomcat as your server, but use net your Undertale, please. Spring webflux was developed because we need non-blocking applications that could work with a small number of threads simultaneously and that could be run with some hardware resource. In Servlet 3.1, an NIO API was provided, but your use doesn't correspond to the rest of the API of Servlet API and to all the concepts behind Servlet, which has blocking contracts. And these factors were decisive for the development of a new API that was used independently of the execution time and in a non-blocking way, which was possible with the servers, net or Undertale and Jet, for example, that consolidated themselves in the asynchronous and non-blocking operation. And the last one, in March of this year, Spring Native was launched. The proposal of Spring Native, which is in the beta experimental version, is to provide official for compiled Spring applications for native images with the Graal VM. Spring Native has some advantage of using the native image, for example, less memory and use it and faster startup. And having this native image, we obtain executable code through the AOT, ahead of time compilation. Graal VM statically analyzes all dependents, leads, and JDK and others. Generating an executable, in the early compilation, metadata is discarded. Whatever is not used for the application work is discarded, leaving only what is necessary to run the application. And it's all. I speak so fast today. These are the references that I use in this presentation. We use the main Spring documentation for this presentation. And so.
Okay, thank you, Camila. So if there are any questions, please let us know. But I just have one question about reactive program with Spring. What do you think about the feature of Spring in this kind of way to code?
With reactive Spring, we can use non-blocking API, we can use Reactor library and RxJava. I think the main features for reactive programming.
Oh, yes. And by the way, is there any features to work with, I don't know, NoSQL database? And
Yes, and with the Spring Data Reactive, with Spring Reactive Data, we can work with MongoDB and in a synchronous mode and unblocking. We can work with Cassandra, if I don't forget this. And we can work with relational databases also. We can work with R2DC with MySQL, MySQL Server, and others. And work with DynamoDB also.
okay, okay, guys, that's time to you fire your question. Please let us know if you want to know more, some tips. Camila, could you share your slides to us, please? Is there anywhere?
Uh, I will upload them and send after to
Okay,
you.
don't worry. So please, if you're here, please follow her, where you can check out the slides and get more information about this amazing presentation. If there is no questions, thank you, Camila. That was a great presentation. And remember, next week we have another presentation. This one also about Spring. Next one will be with Josh Long about cloud native Java. So if you're here, hope you to see you next week. Bye bye. Thank you, Camila.
Thank you. Bye bye.